Hi there and welcome. It's time for Physical Sciences and this is Tinyiko Wamachapko Salama Mkelaka, and I hope we're going to have a fabulous lesson in Physical Sciences, and of course we're taking it from grade 10 to 12. The whole FET is catered for. Today we're looking at lesson number 38 and we're looking at moment of a force, work, energy and power. Okay, and let's look at this now. Mechanical energy. Mechanical energy equals the sum of gravitational potential energy and kinetic energy. And to sum that up mathematically, ME for mechanical energy equals to EP plus EK. Okay, and when we have a closed system, total mechanical energy is conserved. What do we mean by it being conserved? We mean that it would remain constant, and that is only when we have a closed system, sometimes or more oftenly in science referred to as an isolated system, meaning that there are no external forces acting on that system there. Let's have a look at this example here. A brick of mass 5 kilograms rests on a wall 30 meters above the ground. Calculate 1, the potential energy of the brick. Okay, EP equals M times G times H, and we have seen this from the previous lesson, so I don't have to worry much about you being introduced to the formula, so I'm just writing it down as it is. So mass of the brick is 5 kilograms. G is always taken as 9.8 times the height. How far above the ground is the brick? It's 30 meters above the ground. So you make use of your calculator. It's 5 times 9.8 times 30, and then you get your answer to be 1,470 joules. Okay, that is the unit of measurement of energy, joules. So that is the what we call the potential energy of the brick at that height above the ground. If I want to know what the mechanical energy of the brick is, okay, calculating the mechanical energy of the brick. Now, mechanical energy is equal to EP plus EK, the sum of potential energy and kinetic energy. So that will be equal to 1,470. That's what we have calculated for EP. Then the question is, what do we have for EK? Remember, EK is half mv squared, but we are told that this brick rests on a wall. Okay, if something is resting, it means it's not moving, and therefore it tells you that this V is a 0. Now, if that V is a 0, it means your kinetic energy is 0, because that is the energy of motion. Okay, EK. So the total kinetic or total mechanical energy of the brick, it's equal to 1,470 as well. Okay, now let's look at this one, an interesting one. It says the brick is now allowed to fall. It's no more resting. Calculate the kinetic energy of the brick at a height of 20 meters above the ground. Now, for us to do that, we will need to know what is EP at that point. EP at 20 meters above the ground will be mass times G times H. So you'll have 5 times 9.8 times 20. And what is that? Okay, that is 5 times 9.8 times 20. Okay, and then the EP at that point is 980 joules. Okay, now by virtue of looking at this system here, we will assume that this system is a closed system. Okay, now if it is a closed system, what did we say about mechanical energy? It is conserved. Okay, what we know is that mechanical energy is always equals EP plus EK. Now the mechanical energy, we found it to be 1,470. That will be equal to what is EP at 20 meters above the ground is 980 plus EK. The question wants us to find out what EK is, okay, at that point. Therefore, EK equals 490 joules of energy. Okay, so this is a beautiful question, and you can see once you master this, you can actually enjoy working on it. Let's look at this last part of it. Find the instantaneous speed of the brick at that height of 20 meters per second. Now, EP equals half mv squared. EP we have just calculated at 20 is 490 equals half times 5, which is the mass of the brick, times v squared. Okay, now this works out to be what? 490 times 2, it's 980 divided by 5, 196. Therefore, v equals the square root of 196, and that gives us square root of 196. That gives us 14. Okay, all right. So that's a good one. That's a it works out to be a perfect square. All right. Okay, so that's how you work on this kind of things here. Let's meet in the next section of the lesson.